Hello children, today we are going to learn about basic proportionality theorem and its converse. Basic proportionality theorem is also known as Thales theorem. So let us first get into the statement of this B.P.T. B.P.T stands for Basic Proportionality Theorem. So let us read the statement. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Theorem is a statement. Statement is a sentence which is either true or false but not both. So theorem will be most of the times a conditional statement. What is a conditional statement? If dash, then dash. If something is given, prove something. That means theorem is a statement which is again having two statements, that is given and RTP. Given and RTP. That means if you read the statement perfectly, you will have RTP and given both in the statement itself. That is the reason I have highlighted the statement with two different colors. So children, let us first understand what is given. In a triangle, I am taking a triangle called A, B, C. If a line is drawn parallel to one side, that means I am drawing here DE, a line parallel to one side, mean DE is parallel to BC. If a line is drawn parallel to one side to intersect other two sides at two distinct points, mean this DE is intersecting AB and AC are the two lines at two distinct points, mean at D and E. I hope you have understood the given part. So let us mention it as soon as we have understood. Given. What is given, children, here? In triangle ABC, DE is a line drawn parallel to BC. So we have clearly mentioned about given. Now let us go for RTP, second part of the theorem, right? What is RTP? This DE is dividing other two sides. Which two sides it's dividing? It's dividing AB and also AC. Now he says as to prove that it is dividing both the sides in the equal ratio. That means here part by part on the left side, that is nothing but AD by DB is equal to right side again part AE by another part of the line, that is EC. So AE by EC. I hope you have understood what is RTP. Once again, children, DE is drawn parallel to BC. Then we need to prove that this DE is dividing this line and this line into same ratio. That means AD by DB is equal to AE by EC has to be proven. Children, we will have a small construction here in order to prove it. So whatever you have done till now was a drawing based on the statement. Construction is something that you're going to draw extra for your convenience. So children, here in this figure, I want to join this BE. So let us join this BE and CD. Two things I have done, and also draw two perpendiculars, that is EM is one perpendicular from E to AB and DN is another perpendicular. What did I do, children? Here I have joined this BE and CD. Then I have drawn this EM perpendicular and DN perpendicular. I hope you have understood this. So now let us mention whatever we have constructed. First, join. What did we join, children, here? BE, CD, and draw. What did we draw here? EM perpendicular to this one. EM perpendicular to AB. So let us write EM perpendicular to AB, comma, one more perpendicular we have drawn, that is DN perpendicular to AC. Let us now go to the most important part of the theorem called proof. So children, here we need the ratio AD by DB and also AE by EC, and we have to prove that these two ratios are equal. So on AD, on this AD, what is the triangle situated? ADE. I will take this ADE. And on this BD, what is the triangle situated? That is BED. Let us find the ratio of the areas of these two triangles. Area of triangle ADE by area of triangle BDE. So what is the formula for area? Half into base into height. And for this also same, half into base into height. So half will be cancelled, but base and height are different, so you can't cancel them. So children, let us get into this triangle ADE. In this, what is the base and what is the height? AD is a base and EM is the height because we have drawn it perpendicularly. AD is the base, EM is the height. So let us mention it. AD is the base and EM is the height. By, in the other triangle, children, what is the triangle in the denominator? BDE. So here it is an obtuse triangle. So in obtuse triangle, children, let me do it here. This is obtuse triangle. This is acute angle triangle. In acute angle triangle, when you consider this as a base, this will be the height. But when in obtuse angle triangle, when you consider this base, then the height will be outside the triangle. In acute angle, height will be inside. Obtuse angle, height will be outside. So children, here, when we consider this BDE triangle, what is the height then? Height is outside, that is EM. So let us write it as base into height. What is the base here? BD is the base and EM is the height. Hope you have understood, children. When I took this AD is the base, EM is the height. When I took this BDE, base is BD and the height is same EM. So now when we proceed with this, EM will be cancelled. Then what is the statement that you are getting? Area of triangle ADE by area of triangle BDE is equal to what it is, children? AD by BD. Keep this as a first equation. So children, we got now AD by DB. AD by DB is nothing but the left side of the RTP. Now still we need to get this right side, that is AE by EC. Now what is a triangle which is on this AE? ADE. What is a triangle which is on this EC? CD. So we will take these two triangles now. Let me shade this triangle, whatever I am talking about. Find the ratio of their areas. Area of triangle ADE by area of triangle CDE. Formula is same, that is half into base into height, half into base into height. So half of cancel. Now let's go for this. First let's go for ADE. Here earlier we consider this as a base. Now we are not considering that. We are considering this as a base. When you consider this as a base, what is the height going to be? dn. So let's mention that. AE into dn by. Now when we take this triangle, children, CDE, what is the base? CE you are considering. And what will be the height then? Height will be dn, because I explained in obtuse angle height will be outside the triangle. So now base is CE or EC, you can write EC, and height is dn. So children, can you cancel it here? Yes, dn can be cancelled. What is this statement here you are getting then? Area of ADE by area of CDE is equal to, what did you get here? AE by EC. This is the second equation. Children, when we observe the first equation and second equation, in both numerator is same, ADE, ADE. What about the denominator then? Denominator BDE, CDE. Let us look at these denominators. BD is this triangle and CD is this triangle. Both the triangles are on the same base and between same parallels. That means this BDE area must be equal to CDE. Let us first mention that area of triangle BDE is equal to area of triangle CDE. Why it is? Because you can write, because they both are on the same base and between same parallels. So children, numerator is equal and even denominator's area is also equal now. So that means left hand side of first equation, left hand side of second equation, both are equal. So you can conclude it saying that therefore first equation is equal to second equation. What is there in the first equation right hand side? AD by DB is equal to second equation AE by EC. So children, this is what he asked us to prove. AD by DB is equal to AE by EC. Hence, it is proved.